When we talk about how fast a system is, two words get thrown around all the time: latency and throughput. Now, a lot of people use them like they're the same thing, but they're not. They actually represent this fundamental trade-off. And honestly, getting this difference right is the secret sauce to building systems that feel fast, work like a dream, and don't cost a fortune. So, let's dive in.
And that brings us right to the big question. What are you really trying to optimize for? Is it all about raw speed, getting one single thing done as fast as humanly possible? Or is it about capacity, just getting the most amount of work done over a period of time? Well, as you're about to see, you almost never get to have it both ways. To get a feel for this, let's use a super simple analogy. Imagine you're turning on a water faucet. That little bit of time you wait for that very first drop of water to actually come out, that's your latency. Now, once it's flowing, how many gallons of water are gushing out every minute? That's your throughput. See? One is about the initial wait, the other is all about the overall rate.
Okay, so with that picture in our heads, let's get a little more formal and just lock in these definitions. It's actually pretty straightforward. Latency is all about the how long. It's the time it takes to finish just one single thing, like loading a web page. Throughput, on the other hand, is about the how many. It's the rate of those operations over time, like how many requests your server can handle per second. So think of it as response time versus total capacity.
And this is where we get to the heart of it. I mean, in a perfect world, we'd have zero latency and infinite throughput, right? But here on planet Earth, pushing to make one of them better often means the other one gets worse. This is that fundamental trade-off that every single engineer has to wrestle with.
So why would you want to focus on low latency? Well, it really all comes down to the user experience. A system with low latency just feels snappy. It's responsive. It also cuts down on what we call tail effects. Those super rare but incredibly frustratingly long delays that hit just a few users. And for anything real-time, like video games or stock trading platforms, that kind of responsiveness isn't just nice to have, it's absolutely critical. Every millisecond counts. But, of course, that speed comes at a cost. To get that instant, right-now response, you're usually processing things one by one, and that can be kind of inefficient. You might not be getting the most out of your expensive hardware. So you're basically paying a premium for that speed, both in efficiency and just straight-up infrastructure costs. Okay, now let's flip the coin and talk about optimizing for throughput. The huge win here is efficiency. I mean, massive efficiency. By grouping tasks together into big batches, you can just chew through a tremendous amount of work and get way more bang for your buck. This drives down the cost of every single operation, which makes it absolutely perfect for those giant bulk workloads.
But you knew there was a catch, right? To get that amazing throughput, you're usually collecting work into a big batch before you start. And while that's happening, well, individual requests are just sitting there, waiting in line. This means the time it takes to get that first result back, your latency, can go way, way up. And you can immediately see why this would be a total disaster for something like an interactive chat app.
All right, theory's great, but let's make this really concrete. I want to tell you a little story, a tale of two printers, where each one was designed with a totally different priority. So here's the scenario. You've got a 10-page document, and you need it printed right now. You've got two different printers you can use. Let's check out their specs.
So, printer number one is all about low latency. It starts up really fast, only takes 10 seconds to spit out that first page, but its overall speed after that is, well, it's a little slower. Printer number two is a throughput machine. It has this long 20-second startup time, but once it gets going, man, it prints twice as fast. So for our little 10-page job, which one do you think is going to win? Okay, first up, the low latency printer. It's got that 10-second startup for the first page. Then you have 9 more pages, and they take 2 seconds each, so that's another 18 seconds. Add it all up, and the grand total is 28 seconds. Not bad. Now let's see how the other one does.
And now for our high-throughput printer. It has that really long 20-second startup, yeah, but then it just flies, printing the next 9 pages in only 9 seconds. The total time comes out to 29 seconds. So for a small job like this one, our low-latency printer actually wins. But look at that. It's so close. Only a 1-second difference. But what happens if the job size changes? Let's say your boss comes over and now you need to print a 100-page report. You think the winner stays the same? For a 100-page job, the high-throughput printer crushes it, finishing in just 119 seconds. So why the change? Well, because that long 20-second startup cost is now just a tiny fraction of the total job time. Its incredible speed completely takes over.
The supposedly faster, low-latency printer, it would take almost 3.5 minutes. With a bigger workload, the winner just completely flips.
So the lesson here is absolutely crucial. The best choice completely depends on the type of work you're doing. There is no single right answer. If you've got lots of small, interactive tasks, you go for latency. If you've got huge, bulk jobs, you optimize for throughput. Period.
So let's connect this back to the real world. Where do we actually see these different design choices in the technology we're using every single day?
You see this divide everywhere in practice. Low latency is king for anything that needs immediate, right-now feedback. We're talking about financial trading, online gaming, instant messaging, all that stuff. High throughput? That's the priority for all the massive background jobs, churning through analytics data, encoding a video for streaming, or backing up your entire photo library to the cloud.
So how do engineers actually do this stuff? Well, to slash latency, they'll use tricks like caching to keep data physically closer to the user. To crank up the throughput, they'll rely on things like parallelism and batching to just get more work done at the same time. It's really all about picking the right tool for the job. Okay, before we wrap things up, I want to go over a couple of really critical takeaways, and also some of the most common mistakes that people make when they're thinking about these metrics. This is where the rubber really meets the road. Here it is, the single biggest pitfall: just trusting the average. Your monitoring dashboard might show an average latency of, say, 200 milliseconds, and you're thinking, great, we're fast. But that average can totally hide the fact that maybe 1 out of every 100 users is sitting there for a full 5 seconds waiting for a page to load. Those awful, frustrating spikes are called tail latency, and believe me, that's what users actually remember. And that brings us to our final and most important thought. A system's performance, it isn't just a number on a graph. It's a real experience for a real person. And while we as engineers might be looking at averages, our users are the ones actually living through those worst-case scenarios, what we call the 95th or 99th percentile. So the question you have to ask is, are you designing for the average, or are you designing for them?